Hello everyone and welcome back to the shop. In this week's episode I'm going to replace this temporary table with something, well, a bit more over-engineered. What I've been using so far is this simple desk which just lays on these plastic sawhorses, and it is quite a good solution because it gives me the flexibility to move the table around or even fold it away when I need a floor space. But I'm currently on the lookout for something bigger, more rigid and more permanent. The problem is that the shop is 2 meters wide, which is barely enough to do some serious work here. So I cannot afford to have a table which would permanently sit here. My father had a similar problem and he came up with a tilting table which could be put up when it wasn't needed. I'm going to lavishly steal his idea and hopefully improve it. But you hear that? That's the kind of wall I need to work with. It eventually has to hold about 100 kilograms, which is probably the final weight of the table. And therefore the mounting features of the table will be heavily influenced by the fact where I can put them on the wall. And it also dictates the dimensions of the table because there are limited options where the table can be mounted on the wall. So this is the ballpark of the problems that need solving, and enough talking, let's cut some metal. So this is the material for 2 mounting brackets which will get screwed onto the wall. So let's take a look at the components and how it will be put together. I originally thought that I will use only one for each side, but seeing this now, I think I will double it and weld it together to make it stronger. Onto this part I will weld these 3 pieces in this way, creating a big C or G maybe. So here is the wall, and this part will receive a hole and it will act as a pivot point for the tabletop to tilt around. These angles look kind of odd, but those are for protecting against bruises, because this part will be sticking out of the wall quite a lot and I can see that I will eventually hit this with my legs. So I don't want any sharp corners, 90-degree angles and so on. So this 30-degree angle I will eventually fill with some 3D printed part which will be nicely round over and protect me from hitting this quite hard. The tabletop will be attached to the mounting bracket in this way, and it will tilt up around a pivot point which will be somewhere around here. And that means I need to create a round over on this part so it doesn't get in the way of the movement. So that's enough of explanation, let's do some work. So the mounting plates are finished and they will get secured to the wall by a 10mm threaded rod. I'm not sure how precisely I can drill into the wall, so that's the reason why I drilled a 14mm hole into the mounting plate. That will give me some wiggle room so I can fine-tune the final position of the plate on the wall. The next order of business is the pivot point. I need to put a hole somewhere around here and create a round over on this edge. Okay, long time no talk, let's fix it. So, for past few minutes you saw me making a large hole and you might be wondering what the hell am I doing, so I'll tell you. Usually when you want to have two pieces that will rotate against each other, you will drill a hole, actually 4 holes right through them, and put some long screw, something like this one. And preferably the one with that doesn't have the threads all the way up. You might think that this would be a sufficient idea, but the screws are not made to be used that way. They are very good at handling axial loads, which means pulling them apart, but they are very poor for handling radial loads, which is this way. And if you take into account the thickness or low thickness of this tubing, then I think this would be a recipe for disaster. So, my idea on solving this problem is this large hole. It will receive a small round tubing such as this, and it will get welded inside. The counterpart will be made the same way, and both of these will be connected by this lump of steel. It has 14mm in diameter, and when packed with grease, I think it will create the best hinge I can ask for. So the mounting brackets are finished and now it's time to put them on the wall. This vacuum cleaner attachment is just amazing. Watch. I will fix the threaded rods into the wall with this 2-compound chemical anchor. So, as you can see, something happened here. These were the threaded rods which I just put inside, let it dry a little bit, and they just discovered that I cannot put the mounting bracket on because the holes are off. And I mean not like 2 millimeters off, but like 10 millimeters off. So I didn't have any other option than just to cut this off and create new holes and put new rods. This time I created this template which will tell me if the position of the holes is correct. So this is how the mechanism of the table will work. These pieces are the ones which will be in this direction. And I need to drill the same hole and pack it with the same round tubing as on the mounting bracket. I also marked the holes for attaching the top of the table to this frame. I think it's time to put the mounting brackets on. I will use a combination of flat washer, spring washer and acorn nut to cover the thread. But first I need to cut the thread to size. So this is it. This is how the table will look like. This is the correct depth, and it will be wider, about 10 centimeters in total. I'm a little bit worried about the height of the table, but I can always cut these posts in half and just make them a little bit shorter. The next order of business is to measure the final width of the frame. Then I will cut the front and back pieces, weld it together with these ribs. So let's focus on that. The biggest welding session is finally over and the assembly table starts to take shape. Some of the welds look really nice, for example like this one, but some of them are not so nice, but they will still do the job. The table is much lighter than I originally thought it would be, and the rigidity and the smoothness of the operation is something that I'm very pleased with. What I'm just amazed about is the level of perpendicularity of the table. Both of the diagonals are within 1 mm each, which is far more precise than I originally thought it would be. What needs attention though are the angle brackets, especially the round over. The bottom round over works perfectly, but I forgot to add the round over on the top. So right now I can tilt the table up, but once I would add the tabletop, it would hit the corner when tilting. So I need to recreate the same round over on the top, and I hope I will be able to do this when the angle brackets are on the wall, because now they are in the perfect position and I don't want to redo this again. So I'll focus on this, and then I'll take a look at the legs so the table will be freestanding. Okay, let's call this fixed, and while I'm at it, I will grind the weld beads so they are perfectly flat and ready to receive the tabletop. Okay, the grinding is done, and now it's time to level the table and build the legs for it. The legs will be connected to the table via the same type of joint, so I'm just marking the position of the hole and the position of the tabletop. So I attached both of the legs, and then I realized that there is too much play in the joint. So I welded a flange on the opposing side and pulled the peg through it, and now it looks quite nice. The peg is still moving freely inside of the joint, so I have to fix it somehow in place, but not too tight so it doesn't affect the movement of the leg. So the legs are on, and the last thing, construction-wise, is to create some sort of a locking mechanism which will keep the table safely in the upright position. I mounted some sort of a mock-up of the tabletop so I can measure the exact position when the table will be up, and let's take a look what I came up with the locking mechanism. My idea of locking mechanism is to add this tubing between the mounting brackets and weld it together. Then weld on the tubing this type of notch, and the hole in the notch will be registered by this lock, something like this. The lock will be on both sides, so it will be more sturdy and more complicated to open for my son. Okay, so that's done, at least the metal fabrication part. Now I have to cut to size the tabletop and mount it to the structure. Here's a small tip. Whenever I'm marking the position for the rail, I always use 3 marks. You technically need only 2, one on each end, but if one of your 2 marks is off, you wouldn't notice it. But if you have 3 marks and one of them is off, or even 2 of them are off, then you will notice this immediately. So, the tabletop is cut to size, centered on the frame and temporarily fixed. Now I will drill the holes from the bottom for the screws that will hold it in place. I'm going to use this beautiful blackened M8 countersunk hex shank screw. But first, I need to countersunk the holes. When countersinking, it is better to underdo it than overdo it, because you need to take into account the strength that will pull the screw into the wood when you will tighten it. So this is just a smidge over like 0.5, 0.3 millimeters above the surface. So let's tighten this. Perfect. Beautiful. Okay, 15 more. It looks like I forgot to drill holes or even make them in the frame for the center of the table. Well, I hope this is the last fuck up of this project. And now, for the first time, let's try to leave this all together. Just kidding. Oh, it's heavy. It's done. The last thing I'm going to do is to sand this with 240 grit and apply a wax. So it is the last day of this project and I finally don't have to lift any heavy things. The table looks excellent as it is, and the only thing I have to do is to paint the legs, the frame and the backside of the tabletop. But that's not all. I will be adding other features to this table in time. One of them being a 1 meter wide roll of craft paper, which will be mounted below the tabletop, so I can just pull a sheet of the craft paper and cover the tabletop and do some glue ups or painting or something like that. The second feature I would like to add to this table is a router table. As of now I have this small Makita edge router and I mounted its base to this piece of. I usually clamp this to the tabletop and I have a reasonably large space to move the workpiece around the router bit. I usually do chamfers and roundovers with this thing and it is sufficiently powerful machine. But I think I would like to have something more stationary, because the idea is if you have a jig or a machine which takes a few minutes to set up properly, then it is less likely that you will use this jig, and what's the point of having it if you are not using this? So my idea and my dedication in this workshop project is to make my life easier and so I can move through the projects much faster. So router mounted from beneath, somehow make it move up and down. And I will probably add some T-slots alongside so I can have some sled for making box joints or something more precise or repeatable. And that brings me to a feature number 3, which will be located at that side of the table. In the same way I would like to have a router from beneath of the table, I would like to have a table saw at that side. And as of now, I am not exactly decided what features the saw will have and how it will work and look like and so on. But there are a couple of ways how to do this, and this will be definitely a long time project. I think it will take me 2 or 3 weeks to finish. Feature number 4, which will be located at that corner of the table. And I would like to have a Moxon style vise, which is this big butcher block of wood, which can be cranked back and forth, and you can mount a bigger piece of wood, so you can do some hardwood projects and so on. So Moxon style wise there. That's the feature number 4, and feature number 5 will be located at the bottom of the table. So I will lift it up and follow you there. So the last feature I have in queue for this table is a small sub-table which will be located in this area. So while the main table is in the upright position, I can put down the small sub-table right around here. And this sub-table will be for my stationary circular saws. The green one, the woodworking miter saw, and the blue, the metal cutting saw, which I used predominantly in this project. With these saws, I'm usually cutting long pieces of material, so I need to support it on each end usually. And placing the saws on the tabletop and then balancing the 3-meter metal profile is just a nightmare. So this will be a small table just dedicated for this type of operation. So this is the current state of the table and some future projects, which I will definitely make video for each of the feature. And thanks for watching, and hopefully see you next time. Bye.